We are moving on to the last section of chapter 15 that we're going to cover, and that is the ambiguous case. So I had asked you in previous lessons to name the 5 methods of triangle congruency, and those were HL, which you use SOHCAHTOA, and then there was side, 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 angle, side, which uses the law of cosines. And then there was angle, side, angle, and angle, angle, side, which was the law of sines. And then I mentioned that we were going to talk about why is side, side, angle not a method to prove triangle congruency. So many of you have said, oh, side, side, angle. And here's how you know that side, side, angle is not a good case, because it's ass backwards. This is the same thing as angle, side, side. No, no, no. But that doesn't mean that you still can't have a triangle. It just means that you can't say that this triangle and this triangle are congruent. The triangle exists, but they're not congruent. And how does that happen? So that's called the ambiguous case. So, calculator for sure. You absolutely need to have your calculator. If you don't, push pause and get it. Okay, I don't have my little marker tray, so I gotta try and hold all these markers at the same time I teach you. And then I have to try and open them, which is never an easy task. Okay, if I tell you that the sine of some angle, theta, is 1/2, you would say 30 degrees. So let's look at a quick sketch of the parent function of sine. Okay, so 1/2, I don't know, 1/2 is there-ish. There are 2 places where the sine is 1/2. There are 2 angle measures. And one of those angles is here, 30 degrees, and the other one is here at 150. You need to be super careful about notation. Here, you're solving. You're finding theta. There are 2 answers, 30 degrees and 150 degrees. However, if you use inverse notation, so remember, inverse notation is this funky looking, that's the graph. It's a very poor representation, but that's the graph-ish. If I ask you the inverse sine of 1/2, the answer is 30 degrees and 30 degrees only. So the difference is here you're solving for theta, and here I'm giving you the measure of the sine, you find the measure of the angle. They mean 2 different things. Okay, so 2 places where the sine is 1/2, 30 degrees and 150 degrees. Okay, so let's keep that in mind. I'm going to make something up. Okay, so I'm going to make up something. Let's say I tell you that the sine of the angle is 0.63. Okay, I'm just making this up. Okay, well the sine is 0.63 in 2 places, in 2 quadrants. Oh, sorry, I have such a hard time opening the markers. In the unit circle, the hypotenuse is 1. Sine is opposite over hypotenuse. So the sine is 0.63. I can find this angle using my calculator. So you're going to do inverse sine of 0.63. Make sure you're in degrees, and you should still be in degrees from the previous homework you did. So second sine 0.63, and that is about 39.1 degrees. here comes the problem. That's not the only place where you can have a sine of 0.63. The sine can also be 0.63 in quadrant 2. The sine can also be positive 0.63 in quadrant 2. Okay, so 39.1 degrees represents the reference angle. This is the whole huge concept about side-side angle. Okay, there are two places where the sine can be 0.63. Positive 0.63 in quadrant 1 and positive 0.63 in quadrant 2. So the reference angle in quadrant 2 is 39.1 degrees. The reference angle in quadrant 2 is 39.1 degrees. The value of that entire angle is 180 minus 39.1, which is 140.9 degrees. So the sine of theta, 0.63, that's two places, 39.1 degrees and 140.9 degrees. Okay, do a quick check. Do a quick check on your calculator. Say the sine of 39.1, sine of 39.1. Oops, I typed it in wrong, sine of 39.1, and you get 0.63-ish. Type in the sine of 140.9. The sine of 140.9 is about 0.63. And if you notice on your calculator, the two answers for 39.1 and 140.9, exactly the same. Oh, so here's what happens. We're going to use the law of sines, and I'm going to create the side-side angle case. Okay, so I'm going to give you that angle A is 13 degrees. I'm copying this from the book, one sec. Okay, so I'm going to tell you that angle A is 13 degrees. Side A is 12. And B, side B is 5. You know your Pythagorean triples, 5, 12, 13? Don't be confused. This is an angle 13, so don't think, oh, it's a 5, 12, 13. Nope, unfortunately it's not. Okay, so this is what I highly recommend that you do. You have angle, side, side. Angle, side, side. Okay, so that's the ask case. That's how you know it's bad. So I would put a star and let yourself know that this is called ambiguous. Do you have to do this? No. But you will forget that it's ambiguous as you start plugging and chugging. So I highly recommend you star the problem, and I'll show you what's going to happen. Okay. I'm going to set this up using the law of sines. I know an angle, its opposite side. So I'm going to start with the sine of 13 degrees over 12. And I know side B, so now I can find the sine of B. And I like to use beta. It's fancy. Okay, I cannot stress to you enough that you need to store values in your calculator. If you don't store, and down the line as you're doing the problems, you're going to be off by tenths, which becomes being off by degrees, being off by inches, centimeters, whatever. You need to store, store, store. Okay, so let's go and do some solving here. And I'm going to show more steps than I usually show. So this is going to be 5 times the sine of 13 degrees over 12 is equal to the sine of beta. This is going to represent the overall sine of the angle, so I need to use the inverse key on my calculator. So 5, I'm showing more steps, and you'll understand why in just a minute. So 5 times the sine of 13 divided by 12 is 0.0937296606. Leave the number in your calculator. So for writing it on the board purposes, I'm going to write it as 0.09. I hope that's right. That seems really small. Okay, so now I'm going to do second sine of that answer. So second sine, second negative key, and it says 5.3782053332. So essentially, the angle measure of this, the measure of this angle is 5.4 degrees. Okay, so where are we? 5.4 degrees. That's awfully small. Okay, so we can find the third angle. We can find gamma. So gamma is 180 minus 13 minus, it's not 5.4. It's not 5.4. It's the number that's in my calculator. So 180 minus 13 minus the previous answer, 161.62. My triangles are never drawn to scale. Obviously, this angle is not 161.62. So gamma is 161.6. Nearest tenth is fine. Oh, you know what? In the previous video, I said hundredth. Let's do hundredth. 5.38. $161.62. Okay. How do you round? You should follow the directions. So yesterday I said hundredth. I don't want to go back on what I said, but usually we do tenth, not hundredth. So my apologies. I'm not going to take off points. It's not a quiz. It's not a test. So either tenth or hundredth. I'm going to do tenth, even though I said hundredth previously. My apologies. Okay, great. We're done, but we're not. So we just found out that I'm going to erase to here. So you did the calculator and you got that the sine was 0.09. The sine was 0.09. Okay, so what I just erased, there are two places where the sine is 0.09. So the sine is 0.09 in the first quadrant, but the sine could also be 0.09 in the second quadrant. There are two possible answers, always with the ambiguous case. However, sometimes that second angle doesn't fit. Sometimes it doesn't exist. Sometimes it does fit. So I'm going to walk you through an example of each kind. So, like I did earlier, but I erased, the angle in the first quadrant is 5.4 degrees. Or it could be 5.4 degrees in quadrant 2. It could be 5.4 degrees in quadrant 2. So, if it's 5.4 degrees in quadrant 2, the reference angle, I'm going to do 180 minus that, and you get 174.62, 17947. So essentially 174.6 degrees. So my answers are 5.4 or 174.6. Okay, I want you to push pause and I want you to figure out why this doesn't work. Okay, so if you said it doesn't work because it doesn't fit inside a triangle, you're correct. What's that mean? So here's my first triangle, and we said that B was 5.38, 5.4, and gamma is 161.62. Okay, So if I draw another triangle, and this right here is what it means to be ambiguous. This was the given information. And we figured out that the angle was 5.4 degrees. But not necessarily. It could be 5.4 degrees in quadrant 1, or it could be 5.4 degrees in quadrant 2 for a total of 174.6. Nope. Doesn't fit. It adds up to more than 180. So in this case, this is why it's called ambiguous, because you don't know about the second potential triangle. This is too big. There is one. Only time you have to worry about this is when you're doing the ambiguous case, which is the AS case. Angle, side, 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 angle, same thing. Okay, this is an example of one triangle. If you have three options, it could be one triangle, it could be no triangle, which is great because then you're done with the problem really quick, or it could be two. And I'm gonna do the two last. So now let's look at an example where there would be no triangle. Okay. Your book uses XYZ, so I guess I'll use XYZ. None of my triangles are drawn to scale. You don't need to use a protractor and draw yours to scale unless you like to do that and you're bored and you want to make your math homework look perfect. So we have angle X is 13 degrees. Woohoo! Super creative. X is 12. Something tells me we just did this problem. And Y is 60. 13 degrees, opposite side is 12. 60 is way larger than 12. So angle Y needs to be a big angle. From geometry, largest angle, longest side, smallest angle, smallest side. And then, I never know how to say it. Is it medium angle, medium side? I don't know, it doesn't really matter. Okay, so here we go. I have angle, side, side. I promise you that if you make a note, you won't forget to check all the special cases. So this is a special case. It's ambiguous. Only time you need to worry about this is for angle, side, side. Okay, and I think I'll show you a little bit of a proof of that, so to speak. All right, here we go. So the sine of 13 degrees over 12 is equal to the sine of Y. I don't know what Greek Y is. Omega, alpha, phi, chi, psi. I think it's psi, which you probably already knew. If you join a fraternity or a sorority house, you will learn the Greek alphabet right away. All right, here we go. So we have 60 times the sine of 13 degrees over 12 is equal to the sine of Y. When am I supposed to use the inverse key? I'm looking for an angle measure. I'm going backwards. I need to use the inverse key. So second sine, second cosine, whatever. All right. So you're going to do this problem, and it's going to say domain error. I haven't even done it, and I already know it's going to say that. Sine 13, enter, divided by 12. This right here is 1.124755272. 1.12. Okay, so push pause. Why doesn't this work? This is outside of the range of the sine function. Look at a sine curve. 1. It is impossible for the sine to be 1.12. 1.12 is here. Graph doesn't go up to 1.12. Done. Finito. No triangle. Awesome. There's nothing more to do. So when you have no triangle, it's like, woohoo, I can be done. Then sometimes you get 2 triangles. You know what? I haven't even looked at the problem, but I bet you it's X, Y, Z, and I bet you it's 5 and 12 and 13. You hear all my, I have a little table with all of my book and my calculator and my markers. All right, here we go. It is triangle XYZ. Angle X is, you guessed it, 13 degrees. Can you see that? Okay, good. X is 12. Woohoo! I bet you can't guess what the next value is. That's exactly right. Y this time is 15. Okay, so I was saying earlier, make sure you know how to use your store key. This is when it's going to become really important. There's going to be 2 triangles, and I only know that because I looked in the book ahead of time. Your book gives some like shortcuts. If this is greater than this, 1 triangle. If this is less than this, it's 2 triangles. I don't memorize, I just do the book. I just do the work. So, angle, opposite side. Again, it's the side-side angle case. Watch out. It could be 1 triangle, first example I did. It could be no triangle, the example I just did, and then this one's going to be 2. So you need to watch out. You always must check for the second triangle. And that only occurs for the side-side angle case. Here we go. Sine of 13 over 12 is equal to the sine of y over 15. So the sine of y is 15 times the sine of 13 over 12. If you're trying to keep up, you shouldn't have to be keeping up, right? This is just a bunch of basic algebra. Here we go. Keep it in your calculator. Keep it in your calculator. Keep it in your calculator. 15 sine of 13 divided by 12. Okay, so the sine of y is 0.2811, 888,179. Inverse, because you're looking for the angle measure. So second sine, second answer. It exists. There is a triangle for sure. And the angle measure is 16.33, 16.3. I'm going to do 10th because I just like 10th better. But here's the deal. That number's in my calculator. It could be 16.3 in quadrant 1. It could also be 16.3 in quadrant 2. So the sine is 0.28. And my calculator said 16.3. Or, you don't have to draw any of this. You don't have to draw any of it. I'm drawing it to hopefully help you understand why there's 2 answers. So, quadrant 1, 16.3 exists. We're good to go. Fantastic. Quadrant 2 is 180 minus that, which is 163.7. This fits. What do you mean it fits? Store the actual answer in your calculator. So store STO, it's above on. Alpha, pick whatever letter you want. I'm gonna choose letter Y because that's, for me, that's helpful. So I know exactly where it was. Choose whatever letter you want. Now I have to find Y. Where is Y? Number 1. Okay, so store the 163 point blah, blah, blah. Here we go. So what does that mean, it fits? You know, I'm telling you guys, opening these markers is way harder than you think. Here we go. You were given 13 degrees, you were given that X was 12, you were given that Y was 15, and we just figured out that Y here is 16.3 degrees. But Y could also be 163.7. That fits. It fits. When you add those two together, it's less than 180. So here, the measure of angle Z is 180 minus 13 minus 16.3. It's not 16.3. It's the number in my calculator. 180. I'm sorry, I'm probably making you dizzy. Walk back and forth, back and forth. 13. 180 minus 13 minus 16.3333. 150.7. Leave this number in your calculator. Miss Babby could keep saying that. It ends up being fine. If you add these two together, if you add all three together, you get 180. I didn't need to use it stored, but sometimes you never know. You never know when the rounding is going to round, and it's going to actually cause your answers to be much off more than they should be. 150.7, store that. So store alpha, I'm just going to put it in A. Use the given information because now I need to find the measure of side Z. So I'm going to say that the sine of 13 degrees, the given information, over 12, the sine of 13 over 12 is equal to the sine of Z, which is 150.7, but it's really 150.66888,301. If you use a rounded, so here's what happens. If you use rounded 16.3, this might be off, which in turn is going to cause side Z to be off. Store as you go. Or if you're super, super, super proficient at using the calculator and you know how to arrow up and blah, blah, fine. I'm not there to check how you're doing it. Store it or use the full decimal answers. It's not 150.7, it's the number of my calculator. All right, so here we go. Z, side Z, so I don't need to use any inverses, nothing like that, is equal to 12 times the sine of 150.7 over the sine of 13. 12 times the sine of that angle divided by the sine of 13. 26.1. I'm not done. I have to go solve the second triangle, but let's stick here for a second. Do a quick check with the triangle inequality. Smallest angle, shortest side. Medium angle, medium side. If you have a better way, like send me a text or something, because I don't think I'm supposed to say medium. Largest angle, longest side. So that's good. It doesn't mean I'm 100% correct, but at least that ratio is true. So, you know, hopefully I'm moving in the right direction. Okay, let's go here. So 163.7 is somewhere in my calculator. I don't know where. So Z, the measure of angle Z, is 180 minus 13 minus 163.7, 180 minus 13 minus, for me it was Y, 3.3 degrees. Okay, so now I can find side Z. So again, I'm going to use the sine of 13 over 12, because that's given information. Could you use 163.7 degrees over 15? Sure, but what if your 163.7 isn't right? So use the given. And that's going to be equal to the sine of 3.3 degrees over Z. So 12 times the sine of 3.3 degrees over the sine of 13 is equal to Z. Here we go. 12 times the sine of that divided by the sine of that. 3.1. Okay, so again, let's check our ratio. 13 degrees. So smallest angle, 3.3 degrees. Shortest side, medium angle, medium side. Largest angle, longest side. Okay, I know it's a lot, but I am going to do one more thing. So let's look at law of cosines is longer. Can you do a problem by law of cosines, reduce it down, and use law of sines? So you'll see what I mean in just a second. Law of cosines always works. Law of sines doesn't always work. Okay, so what do I mean by that? When you draw your 4 quadrants of the unit circle, okay. So you have some sign that's 0.28. We did it earlier. I don't remember what the numbers were. But the sign is positive in quadrant 1 and quadrant 2. All angles in quadrant 2 are between 90 and 180. All angles in quadrant 2 are between 90 and 180. Those angles could potentially fit within a triangle, as we just saw. You can have an angle in quadrant 1, an angle in quadrant 2, and when you add them together, you get less than 180, meaning they can fit. So for example, if, let's say you have 23, I can't think of an example off the top of my head, but I will think of one. So this is cool. You get a quadrant 1 answer and a quadrant 2 answer. Law of cosines, not possible, because in the law of cosines, if I tell you that the cosine of the angle is 0.28, okay, well there's 2 places where the cosine of an angle could be 0.28. It could be in the first quadrant, it could be in the fourth quadrant. Cosine is positive in quadrants 1 and 4. Well, it's impossible to have an angle in quadrant 4 fit, because all the angles in quadrant 4 are between 270 and 360. No can do. So the law of cosines always gives you a correct answer. The issue is many people don't like to use law of cosines because the formula is longer. You can't be lazy, and I'm going to show you why. Well, you can be lazy, but it's not going to help you in these problems. Okay, here we go. So the purpose of this problem is, why can't I just use law of cosines once and then shortcut it to law of sines? Okay, so 4, 5, 8. Side, 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 I have to use law of cosines. Side, side, side. To use law of sines, you need an angle. No angle. Okay, so let's find angle alpha. I like to go in alphabetical order. So let's find angle alpha. So, law of cosines. Now I'm going to use the shortcut. Alpha is equal to the inverse cosine of 4 squared plus 8 squared minus 5 squared over 2 times 4 times 8. If you have no idea what I just did, watch the previous video. Okay, so plug this in. I cheated. I already did it. So you get alpha is 30.8 degrees, if you've done it right. That's it. It must be 30.8 degrees. Fantastic. So you get alpha is 30.8 degrees, and you decide, okay, well now I can use law of cosines. Okay, so let's see what just happened. So now, I'm sorry, I misspoke. Now you can use law of sines. That might be what you're thinking. So I know that alpha is 30.8 degrees. We just found that. And again, if you don't understand the work I just did here, look back in the previous video. I like to use this formula as opposed to the long one. Okay, so 5. Okay, listen carefully. You were given a side, side, side triangle. That's it. It's not ambiguous. It's not the side, side angle case. There is one triangle, and this is it. And I'm solving. I'm going to find alpha, I'm going to find beta, I'm going to find gamma, etc. There's one triangle. Here's what you just did. You want to shortcut it using the law of sines. I'm going to use this information for the law of sines. I'm going to say the sine of 30.8 degrees over 5 is equal to the sine of beta over 8. You've just created the ambiguous case, which is not what you started with. What do you mean I just created an ambiguous case? Side, side, angle. Maybe two triangles. But there can't be two triangles because I gave you one triangle. Oh my God, what is she saying? If you look back, the law of cosines problems, one. Like there was one triangle, we did angle, side, angle, we did angle, side, blah, blah, blah. Today's the first day I'm talking about this two potential triangle stuff. Side, side, side. One triangle, this is it, blah. You want to shortcut it. The information that you are using is from side, side, angle. There's only one triangle, but this says maybe there's two. Okay, plug into your calculator and let's see what happens. Doing your multiplying through by denominators, yada yada. Okay, so 8 times the sine of 30.8 divided by 5. This says that the sine of beta is 0.82. The numbers in my calculator. Okay, second sine, second answer, and you get 55. Or 0.82 in the first quadrant, which is 55 degrees. 0.82 in the second quadrant, which is 124, 125. They both fit. The given triangle, 30.8, 55, okay, 30.8, 55, subtract from 180, do, or 30.8, 125, which one's right? Which one's right? You could use the largest angle, longest side theory. Don't bother. Do the law of cosines the whole way through. You don't ever have to worry about this possibility of a second triangle. So I would not have done any of this. I wouldn't have done any of it. It's shorter, but guess what? It could potentially lead to an extra triangle that shouldn't exist. Don't do it. Use the law of cosines again. This comes up, I think, in your homework. So I'm going to find beta by doing, c squared equals a squared plus b squared, whatever, or the I solved to find inverses in the previous video. I know I'm repeating myself. So beta is the inverse cosine of A plus C squared minus B squared all over 2A, what's A? 5. Okay. Okay, 25 plus 16 minus 64 divided by 40 second cosine. 125 was the correct answer. So you would have gotten it wrong too because you would have forgotten, I'm assuming, you would have just done the shortcut law of sines. You would have gotten 55 degrees and you would have moved on, and it's not 55 degrees. It was the other choice of 125. Law of cosines says one answer, 125.1 I think it is. Yeah. And now I would subtract from 180. $24.1. Okay, so a couple last minute notes. Degree symbols matter. If you forget your degree symbol, it is automatically implied that you are in radians. So, does it matter on your homework? No. Does it matter on quizzes and tests? Yes. And so next year, whether you're in trig or you're in trig honors, the degree symbols are going to matter. It's not just me. You're going to lose points for that stuff. They're considered units. I'm going to work through the homework solutions, and probably going to want to watch this video once or twice and post your questions on the classroom stream. Bye.